Hello everyone, I am from Group 20 and this is our project presentation about dehumidifier. This is our team members. There are 6 people. First one is our project director, Kai Chen. Next one is our assistant technical manager, Yusof. And then our technical manager, Shahran. Our treasurer, me, Anik. And our vice secretary, Afiq. And our secretary, Irnisha.
To start our project presentation, me, Muhammad Shahran, will talk about the introduction of this project. First, let's talk about the prototype description. Dehumidifier is an essential device for maintaining optimal indoor humidity levels and prevents the detrimental effects of excess moisture in our living space. This dehumidifier is different from the commercial dehumidifier as it is very cost effective. This dehumidifier is also possible and easy to place anywhere as it only uses a removable battery and do not need to be connected to the power supply. This dehumidifier only uses Peltier cell as our main drive instead of using compressor, which will reduce the cooperating noise. Next, I will talk about the problem statement of this project. Malaysia has a high level of humidity level because of its tropical climate. The average humidity level in Malaysia is between 70% and 90%. To solve this problem, we will need a dehumidifier, but this is where another problem arises. The commercial dehumidifier is very expensive, ranging price around RM1,000, which will limit the accessibility for individuals with budget constraints. The commercial dehumidifier also not very portable as their size is big and they need to be connected to the power supply. The commercial dehumidifier is not noise friendly as on average will produce up to 65 dB. Next, there are 4 objectives in this project to solve the problem state in the problem statement. First, to build a device which can reduce the humidity level and relative temperature of the surrounding. The second objective is to retrofit the existing infrastructure to make it more sustainable and affordable. Next, to design a low-cost dehumidifier which everyone can afford. The last objective is to create a noise-friendly dehumidifier.
But what exactly is the relationship between humidity and the temperature? It is actually very closely related. High humidity can make the high temperature even feel more hotter and uncomfortable, while low humidity can make the cold temperature feel more piercing. Before proceeding with our project, we have made a survey to know what people think about the humidifier. We want to know if this issue is mainly relatable to the people and if this project can help the society. From the survey, we can see that most of the respondents does agree that the weather in Malaysia is very hot. However, some of them don't know how to use a dehumidifier, so we come to a conclusion that we need to make a simple and user-friendly design for dehumidifier. Next is about the willingness of our respondents to buy a dehumidifier, which is very in answer. We deduce that it might concerns them about the cost of dehumidifier, which is very high in the market right now.
So now, I would like to talk about the project management planning. Firstly, is the brainstorming. So during the brainstorming, we had a meeting and we discussed about the idea of our project and then we come up with the dehumidifier as our main topic. Next, we design the project and we come up with the best design for our dehumidifier. And then we evaluate the design with our supervisor to confirm the final design. And then we went to the lab to fabricate our project. Then we take turn to do the fabrication because some of us have classes. Next is the assessment of project. So we will presenting our project to the assessors in a meeting. Next, we will write the final report.
From the Fusion 360 shown, as you can see, the tray design is an L shape that separates into 3 compartments which are reservoir, electronic compartments and the main compartments. We use a 2-fan design for the casing to increase the airflow inside the main compartment and enhance heat exchange between the smaller cold heatsink and bigger hot heatsink. The removable upper casing of the main compartment and the electronic compartment is to ensure easier accessibility for the maintenance purpose of the dehumidifier. Besides, we use the Peltier cell as the main drive of the dehumidifier. For the reservoir, we do it in sliding form to ensure easier removal of the water reservoir. Some HSE consideration of the product is that since the battery possesses hazard of explosive, therefore we use a 3-compartment style to separate the battery and electronic compartments from the reservoir and the main part of the prototype. From the photo shown below, the wire of the components and the main compartment is facing upwards to prevent the dripping of water along the wire, thus causing a short circuit. Besides, we also routed the edge of the casing to prevent injuries from using it due to an accident. As for the designing, the first software that we use is AutoCAD. The main purpose of using AutoCAD is to provide a 2D open box drawing to ease the printing of laser cutter machine and the assembly of the perspex. Secondly, we use Fusion 360 software for the modeling and animation. By using Fusion 360, we are able to do the exploded view and have a more insight of our product dehumidifier.
So, materials and software. In the table shown here is the list of components, materials, tools and software that we use in making this prototype, and I would like to note a few of them. Firstly, the TEC1-12706 Peltier cell is selected because the cold side of the Peltier cell can produce low enough temperature to reach dew point while consuming minimal energy. Other than that, we use Arduino Uno connected to an LCD and a DHT22 sensor to monitor the relative humidity and temperature of the room when we test out our prototype. Other than that, we selected perspex as the material for our prototype casing because it can withstand heat and moisture. Next are the tools and software. The perspex that we use were cut using a laser cutter machine, and the schematic drawing of the prototype for cutting the perspex was produced using AutoCAD software. To combine the perspex pieces together, we use chloroform, which acts as glue for the perspex, and to hold the perspex together while gluing, we use a few metal blocks.
My name is Shahran Izzat bin Isa, and I will be telling about the working principle and the engineering analysis of our prototype. So for working principle, the first one is thermoelectric cooling. As the name suggests, thermoelectric cooling system rely on electricity flowing through two different types of conductors. When DC voltage is applied and runs from one conductor to the other, there's a change in temperature where the two conductors join. These conductors live inside the ceramic plates of the peltier, thus generating two sides of hot and cold. The second one is dew point temperature. It is the temperature at which relative humidity reaches 100% and air is saturated. When this happens, condensation begins and gaseous air will turn into water at the cold heat sink inside our prototype, thus reducing the amount of moisture in surrounding air. The third one is apparent temperature. It is the temperature felt or perceived by human that depends on surrounding temperature and relative humidity. The apparent temperature increases as humidity increases, thus making human feel more uncomfortable. In our prototype, the condensed water will reduce the humidity of air, thus lowering the apparent temperature. For engineering analysis, the material chosen for our prototype is perspex, which comes with various advantages. The material is lighter and stronger while being shatterproof, thus making it highly customizable through drilling, milling and etc. And compared to other temperature reduction devices, our prototype doesn't use complicated components, which is why it is more repairable if it breaks down. The noise level omitted by it is also lower as no moving part other than the fan is present, ensuring calm and quiet experience to the user. In terms of cost, perspex and other component use offer great balance between price and performance, thus benefiting us in prototyping stage and ensure competitive price for the final product in the market later.
Now, I would like to present about the business consideration. So this is the list of items that I have purchased. The first one is humidity and temperature sensor. Second one is Arduino relay board. Next one is LCD, blue LCD. Next one is Peltier. Next one is fan, heatsink and thermal paste that I buy together in a set. Next one is Arduino component, wiring component, rechargeable battery and a spray paint. So all of these items come out the total cost of RM180 and 80 cents, which is cheaper than most of other industrial dehumidifier.
Here is the reading of initial relative humidity and temperature, and after about 5 minutes of testing the prototype. The most significant output of a dehumidifier is the efficiency, and in the dehumidifier system, the efficiency is calculated in the form of integrated energy factor or IEF, which is by dividing the total amount of water condensed and divided by total energy consumption. We have collected data after 30 minutes of testing and calculated the IEF of our Peltier dehumidifier and got 0.58, which is better compared to average Peltier dehumidifier efficiency, which is about 0.45.
For the problem arising during the assembling of a prototype, first, we face the problem of incorrect measurement of heatsink provided by a supplier. Everything was solved prior as we done our precautionary step, which is to measure the dimension of the perspex a little bit larger. Next, the second problem is that the blockage of airflow from the cardboard causes hot air to recycle back and contribute to the increase in temperature. We make a solution to the problem by cutting the hole at the cardboard at the part of the air intake. Finally, we solve the leakage problem by putting the alkalic triangle at every edge of the reservoir and uses chloroform to strengthen the edge of the reservoir.
After we are done with the prototype, we actually ask for feedback from the users, and all of our users says that our dehumidifier is very easy to use. And then we also ask them to rate our product, and most of them give good rating on the rate of level of comfortability provided by our dehumidifier, showing that our dehumidifier works very well.
Finally, here's our final product of dehumidifier. Our dehumidifier has dimension of 113 mm width, 308 mm length, and 250 mm height. The color of dehumidifier is in white color with the consideration of reflecting the light wave, thus preventing the light from converting into the heat.
As a conclusion, our dehumidifier is very practical and affordable. While it may lack some of the advanced feature, it is noise-friendly and cost-effective, making it a valuable starter option where it meets the Sustainable Goals (SDG 9) for domestic technology development.
Hello everyone, we are from ETP Group 20 with our project titled Dehumidifier. Our dehumidifier functions as to reduce the apparent temperature and the humidity of the air. It mainly consists of three compartments, which is the reservoir, the components compartment, and the main compartment.
Surrounding air from the atmosphere will flow into the casing through the top air vent, and when it comes into contact with a small heat sink, it will then condense into water as the temperature of the heat sink is lower than the dew point temperature of air. The water will then accumulate at the heatsink and drip into the water reservoir below, drying the air and thus reducing the apparent temperature of the surrounding environment.